Today we're going to look at the law of sines, the ambiguous cases. When we're given a side-side angle triangle, we have two possibilities as our answer, because we could have the acute angle or the obtuse angle, and both of them will give us the same sine value. I like to call this case the pain in the butt case, because we have to find the supplement of the first angle that you find, and then you work with two different angles. So let's look at this example. When you have a side-side angle triangle, you have to check to see if there is more than one triangle possible. So what we have here is a triangle where side A is 22.8 feet, side B is 24.9 feet, and angle A is 55.3 degrees. However, what we don't know is what angle C is, and we don't know what side C is. Since we don't know those things, when we do this, we have to consider this triangle here as a possibility, and that is where B is the obtuse angle, but we also have to consider this triangle here, where B is the acute angle. So what I like to do is I like to draw those triangles and think about making them two separate triangles. So here's triangle 1. With angle A, angle C, and angle B. And I know that side A is 22.8 feet. I know that side B is 24.9 feet. And I know that angle A is 55.3 degrees. And then I also draw the other triangle, which is what happens if B is an obtuse angle. Here's A, here's B, here's C. This is still 24.9, this is still 22.8, and this angle right here is still the 55.3 degrees. Now, when we do this on our calculator is only going to give us the sine of the angle of the acute angle. So when we set this up, the only angle we can start with finding is angle B, because it is opposite a known side, and we have this pair of known side and its angle. Since I'm looking for angle B, I'm going to put it on top. So I'm going to say that the sine of B over 24.9 equals the sine of A, which in this case is 55.3 degrees, over side A, which is 22.8. Now, if I want to solve this for sine of B, I'm going to multiply both sides by this 24.9. And those are going to cancel. And I'm going to get that the sine of B is equal to 24.9 times the sine of 55.3, all divided by 22.8. Now, you've got two choices here. You can go ahead and plug this into your calculator and get that the sine of B is equal to so when you do that, you get that the sine of B is equal to 0.897 86. But that's the sine of B, and we want B. So to undo sine, we do the inverse sine. And when we do that, we get that angle B is 63.9 degrees. That is if B is our acute angle here. But we also have to think about, well, what happens if B is not an acute angle? What if it's this triangle and B is an obtuse angle? What we have to remember is that because of reference angles, the sine of 63.9 is equivalent to the sine of 116.1. Because the supplement of an angle and its angle are the same when you take the sine of them, because sine is positive in both the first and the second quadrant. So what I like to do is I like to think of this being my triangle 1 and this being my triangle 2. Now we do need to remember that A is given, and since A is given, it's not going to change in either triangle. Angle C, however, we can calculate by adding these two angles up and subtracting them from 180. And when we do that, we get 60.8 degrees. That's possibly for angle C. We also have to do that over here. What we have to remember is these are the angles that are in my triangle. This is my angle B and this is my angle A. I have to calculate angle C. So if I add those two together and subtract from 180, I get 8.6 degrees. Now, since A was given and side A was given, side A was 22.8 and side B was 24.9, those are not going to change. But angle C, side C can, depending on what angle we have. So in this triangle where B is an acute angle, I'm going to set up C over the sine of C, which is 60.8, equals A, and I always like to work with the angle that I'm given in the first place, over the sine of 55.3. But in this triangle, we have to do the same thing, but now we're going to use 8.6. So little c, or side c, equals the sine of 8.6 over the side c over the sine of 8.6 equals side A over the sine of angle A, which again was 55.3 degrees. So when we work with this triangle over here, we get that side C works out to be 24.2 feet. And when we work with this triangle over here, we get that side C ends up to be 4.15 feet. Now, if we go back and look at our triangle up here, it would make sense that if B is an acute angle, side C is much longer, and if B is an obtuse angle, side C is much shorter. So that's the case where the law of sines gives you two possible triangles.